Hey everybody, this is Larry. This is day 17 of the March Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. It's almost the end. Welcome. Let me know what you think about today's problem. Generate random points in a circle. I usually do these live. If it's a little bit slow, let me know or fast forward because you're master of time. Okay, so actually I've done this problem either recently or something like that, or I remember doing this one. Because I think the naive thing to do, or my first inclination, is to have two variables, right? R and theta, where R is the radius and theta is the angle, right? And then just do a random R and then random theta and then go. But the problem is that it actually it's not uniformly distributed in the circle. Let me pull up paintbrush actually. Give me a second. Technology. Yeah, but the problem is that, and pretend this is a perfect circle, is that if you have two things, right? You have R, which is the radius, and then you have theta, which is the angle. So R would be, for example, let's pretend that's the middle. So R would be the length, and in theory, I mean, you could also obviously draw this from any point. Theta would be that angle that's in between, right? And the problem with this is that actually it's not uniform. Is that it's that I don't know how to prove this, to be honest, and it's just that, and I was wrong about it the last time I was doing this, but it's just that if given that R is if you choose R to be uniform, it actually has bias against the more remote points, right? So I mean, and I don't really have a great way of proving this, at least without like a long mathematical formula. You can probably Google on the internet, but the intuition is that let's say you have the same theta, right? I mean, let me change the color a little bit. Let's say you have, let's say you have, here the same, you have two theta, you have the same theta. Let's say they're the same length, right? And then you have the same, you have a shorter R, but the same theta. In this case, you can see that there's, if this is uniform, there's actually more spaces in between, right? On the top one. So you have to kind of adjust for it because, but there's not uniform because on the top there's more spaces, right? Because of these extra spaces, it means that it's not going to be uniform, because that means that dots are more likely to be biased toward the center of the circle. I think and I actually know the answer to this because I looked it up like the last time I solved this, but I don't really understand the proof, to be honest, or at least like, so I'm just gonna just say it, and the answer is actually you end up taking the square root of a random variable of R, which is the way to do it, but to kind of get, or maybe even, how do you want to, yeah, so basically instead of doing that, you get a random of theta, you get a random of variable, and then, wait, is it square root or square? I actually don't remember. Maybe I need to look that up, to be honest. It's been a long time. Yeah, but I think it's square root. Okay. So, but however, what I'm going to do is not this, which is fine. Otherwise, we could look it up together, and maybe we still can look it up together. So what I'm going to do is instead, I'm going to draw a square box, and then I'm going to point a random, changing the color again. We're going to make random points, and then we turn the first point that's inside the circle. So this is a randomized algorithm anyway. So yeah. So then your question may be, well, but couldn't this go into an infinite loop? Well, the answer is that, well, the circle is clearly more than half of the square, and you can easily do math on, you know, pi r square over r square, which is, wait, is it? No, that's, oh, pi square over 2r square, which is, you know, pi, you know what I'm trying to say. We could do the math, but the point is that you can see very clearly, though, that the circle is bigger than half of the square in area, and because of that, you know that you can actually do this in an amortized or probabilistic constant amount of time to get a dot inside the circle because of that convergence series. That means, you know, like 1/2 plus 1/4 plus 1/8 plus ... and that's equal to that's equal to 1, right? Because that converges to 1, so, or 2 depending on how you start with one operation or not. But because of that, if you just do a random dot and see if it's inside the circle, and then return the first one that is inside the circle, that should be good enough. It does have a worst case. It does have a worst case, you know, bad scenario. But I think that's, for me, that's already that's the way that I would do maybe on an interview, even if it's not the perfect solution. That said, you know, we'll see if we could go with the other one, the other solution later together. Because I mean I know the answer, but I don't know I don't understand the proof very well. I think I did that part last time. But yeah, okay. Let's see. Yeah. Oops. So let's set the radius. And then we just get a random point. We get a random point between of, you know, between 0, 0 and 2 times radius, 2 times radius. So basically we're just doing a square box from we just recenter the 0, 0 and then 2 times radius and 2 times radius on the x and the y, and check if it's inside the circle, and then keep doing it. And as we said, because we know that this is a convergent series, we know that it's going to run in reasonable time, and as long as we, you know, as long as we don't do anything weird. In other languages, you may have to actually make sure that you seed your pseudo randomness so that it doesn't, you don't do something like predictable or something like that. But yeah, okay. So actually, I don't remember how to. I actually don't remember how to do Python randomness. It's been a while, or at least off my head. So I'm gonna Google that real quick. Is it just random.random? Okay. So random got. Oh, I don't know. So random.random gets a number between 0 to 1. So we just times it by. Well, okay. What does that mean, right? So we have 2 of them. One for x is 1 for y, and then basically we want to check whether this is inside the radius of the middle. So actually, yeah, maybe I said this a little bit weird. Maybe I don't even need that. But this is between 0 to 1. So we just have to translate our thing so that, okay, so then we want to actually convert this to random.random gets a number between 0 and 1. Let's convert it to 0.5 and 0.5. So let's actually ignore this. And then now we check if it's inside the unit circle, right? So the unit circle, of course, is if the distance is less than 1 away from the middle. I think that's good, right? Or is it 1 or half? Oh yeah, no, because now it's a half box, so we have to check that this is yeah. So R in this case is, so it's not the unit circle. It's either circle with a radius of 5. Okay. Okay. So then we have, let's just say while true, if x plus y is less than though you would probably multiply it out, so I guess that's just 25, right? Then this is inside, then return well, now we have to, you know, so then we want to times this by the x plus sub.x. Oh, what do we want to turn? This is a list, so then yeah. And I think that's maybe it. Let's give it a quick go. I mean, obviously the answer is not going to be the same, but does it look okay? Yeah, I mean, maybe. Let's copy the second example just to see. I wish they told you whether this is successful, because I guess it's hard to tell from just one case. Yeah, let's give it a submit. Hopefully it doesn't. Oh, why are these answers so close? Well, that's a little bit awkward. Do I have any bias on this one? What? I don't think I have any bias on this one. Maybe I'm wrong as well. First grade. That's weird. I mean, I don't know how. So Leetcode does have a thing that checks the distribution, I think. Do I have a bias here? I mean, it's hard to tell, but it probably looks close enough. But does this have a bias? Maybe we'll have to find out together. I thought this would be good, to be honest, because it should have all the dots independent. Like, I'm thinking about the dots and all the positionings. And this is just saying that my distribution is not good. And there's no way for me to kind of see whether this is good enough to run again, or am I just a little bit unlucky on the distribution? Let me think about what I want to do. I mean, I know the other answer, but I can't really prove it either. This one feels more intuitive, but maybe it's wrong. Oops. Sorry for kind of misleading you if that's the case. I mean, we did pass all the minimum ones, right? So let me double check that we at least have all the negatives and positives. Yeah, I mean, it looks like we at least have, you know, negative numbers on the x and the y, so it's not like I did anything weird. All right, let's give it one more submit, and if it's wrong, then we'll just cheat and go to the other one together. Okay. Okay. I mean, let's all right. Let's do it the other way, and then I thought this would work. And I have to look at the proof for this. But okay. Yeah, I mean, I do actually happen to know the other way as we mentioned before. So we can just do something like for the square root, and then fader is you go to random times pi or something, but I have to do the math in a second. But basically, yeah, we just convert this to this is the polar coordinates, and we have to convert this to we have to convert this to what do we call it, to Cartesian coordinates. Sorry, I'm a little bit stuck on the other one as well. But okay, so yeah, so x in this case is equal to I may get them confused actually. So, but it doesn't matter due to symmetry, but I may get them confused. So definitely, apologies if that's the case. But that is just x is equal to r times cosine of theta, right? Maybe this is it map.pi in Python? Let's do map.pi and then we'll look it up. Something like that, and then return xy. Oh wait, no, I have to set that on. Does this look roughly okay? It looks kind of the same, so I don't know. So let's give it a submit. It might be wrong. I don't remember this is square root or but square root of this. Man, it's either that or I just have a fundamental misunderstanding of this problem. That'll be funny. Alright, let's give it again. If not, then I'm just going to have to look it up because I think... oh man, wow. And I feel like I've done this problem too, so that's a little bit sad that I did not learn from last time. It's loading. Oh no. Where did I done? I definitely have done this problem, but maybe it was on binarysearch.com or something. Okay, so let's look together. Oh, did I mess up? Did I have to do two? I didn't do the math. I was a little bit lazy. Maybe that's why. Because it's 2 pi theta. Yeah. Okay. It's really sloppy today. That's my fault, everybody. I got thrown off by this because I wasn't. I mean, this is so much like either math or trivia, depending on how you want to call it. And again, I don't know how to prove this, so you might have to kind of read it with me, and we'll see it together. I mean, this is just. But this is a good actually picture of why that's the case, as I was saying, because there's more spaces on the outer side, so it's not distributed, and you need, and I do remember that you need the square root of it from learning last time, as I was saying, but I don't, actually I had this solution. Did I mess that up? Maybe I just messed this up. I had this exactly, right? That's weird. Well, at least I would say that my first idea was correct, but, or like in concept, maybe there was some implementation thing. Let me play around with this actually. That's weird because I mean, you know, y'all saw I did this the other way. How do I get back? What was I doing wrong? Okay, so I mean, I think the takeaway is that okay. I mean, I was confident about it, but there was a lot of math that I wasn't sure about. But this is my thing. Which is the same idea. Why, how did I do this wrong or incorrectly? This is a number between a negative 0.5 and 0.5. Huh. Because this is basically this, right? That's weird. I don't know why my solution is a little bit wrong. I wonder. Well, yeah, why is this wrong then? I'm going to try to debug this offline, but it seems like this has the right idea. Yeah, I'll be right back. Hey, I'm back. Actually, so I looked at my old solution. This is my old solution. I figured out why. So the short answer is that I would say precision error. So this is a little bit of a rounding error or precision error. Mathematically, this is correct, and this is why I had issues with it, with you know, with trying to figure out why this is the case. But the answer is that, and this is actually a pretty good lesson for me, though. I mean, I knew about it, but I know of it, but it wasn't in my mind. So maybe it's a good lesson for you at home as well. But the reason is that, you know, and you know, what was my example that I got wrong? Sorry, hang on. So basically, that's actually a kind of hard. I mean, it's not a hard thing. It's just a nuanced thing that, you know, you might not, or I did not do as well. Let's see. Right. Oh. All right. Let's look at what. All right. Let's just look at the first input, right? Oh man. Okay, well, whatever. The idea is that, okay, so basically the input that we were given, and this is actually comes into play a lot with floats and stuff like that, and I was just being very careless because I haven't had to deal with it in a while with respect to Leetcode or competitive programming, but in real life this actually happens a lot, so you should be careful about it. But the idea is that, okay, the radius, the sub.r, the radius constraint that we're given is 0.1, where our xy is equal to, I don't know, some big number, right? Let's just say 1 billion. Then the problem is that, or maybe the other way around, though in this case it's this, but the problem is that given random.random, we actually do not, because we do this thing where we find a number between 0 and 1 and then we multiply it. The problem is that when you multiply it, you actually lose significant digits relatively, so it actually was not precise enough as a result. And what I mean by that is that when you have something that's small, actually the xy doesn't really matter. It's just that, or well, maybe it does, but it's just that by comparison, when you multiply it, you can think about it as maybe the other way is a little bit easier to visualize. Let's say you have a radius that's really big. If you have a random number that's really small, between 0 and 1, it might look like this, and it may not. I mean, I know that has more zeros, but just an illustration. That means that instead of getting all the possible, because we times random variable times radius here, it actually may make it so that each step is now 1 instead of the smallest possible, right? And as a result, that's how we get the wrong answer. So it's just not precise enough. And I know that this math is very rough, but that's the idea, is that because we multiply it, the error, the step error, if you want to call it that, of random, that's between 0 and 1, we now multiply that by another possibly big number. So, and from that, it magnified the steps versus instead of getting the precision right. So the way to solve this is actually just by doing the calculating the in math.random, there's a uniform function that lets you get the range of stuff. So then we can just do from negative self.r to self.r, same thing here, and oops. And once we've done that, this is the distance is now self.r square. We can actually cache that, of course, if you want to be performant. And then now we don't have to multiply by x here, and that should be good enough. Well, let's give it. So basically, the short answer was that we were just not precise enough, even though I had the right idea, and this was. Oh, I set that in. Did I have a typo? Oh, whoops. No. I mean, I do have a typo is the answer. Oops. Oh, I wasn't even. Is all even a variable? How did? Oh, no, it's self.r. Okay, because everyone was returning the same answer, so of course as well. Okay, so this looks good. And also one thing to note is that they actually tell you whether it is accepted in this wheel versus in the daily problem wheel. So that's a little bit awkward, because that was one of my trick thingy, was that I couldn't able to test it. But yeah, so now once we send a submit, it looks better. So yeah, so the idea is just precision errors, and I like the solution a lot more because I don't have to memorize or prove any really hard problem. I like that in this one. You just basically have a circle, and you just put dots that are random. You know that drawing dots in a square is going to be uniformly distributed. It's just about whether it is inside a circle or not. And actually, coincidentally, that's how you do numeric integrations as well. So if it's good enough for integration, is good enough for us because it's going to be uniformly distributed. Cool. And as I said, because we know that this is let's put it here. Actually, we know that this is true greater than half the time. Then the running time is going to be probabilistically constant, because it's just going to be 1/2 plus 1/2 of the time it ends at, times 1 plus 1/4 times another operation times 1/8 for another operation, ... And this is, of course, equal to 2, right? So this is going to take 2 loops on average. Less than 2 loops, because we know that this is greater than 1/2, right? But yeah, in terms of space, obviously we don't really use that much space. It's constant space. Cool. That's all I have for this problem. It's a little bit messy, and I kind of jumped around, and I'm not going to go with the other solution. You can Google it and look it up, because I don't know. I don't find that useful. I mean, if you want to learn math, if you want to play around with all that stuff, feel free to upsolve it yourself. But for me, I don't know. I would also say I definitely need to get better at that, the math, the trigonometry. But that's not today, so we'll talk about it later. Cool. That's all I have for this one. Let me know what you think. Even though I had a simple and correct answer, I definitely had some issue of the implementation that I learned. So it was good for me. Okay, that's all I have. Have a good day. Take care of yourself. I'll see y'all later. Bye-bye.